Howdy guys, Rock Papa here. Hope you guys are doing well wherever you are and having a great day. Welcome to the Minimalist Cottage and to the Petrological Porch. Today we're going to start a new video series, and this video series is going to be called Chasing the Wilson Cycle. By the way, I hope you can hear me. I got a lapel mic for the first time, $10 on Amazon. Yeah, sometimes it doesn't like what I'm saying, so it just quits listening. Anyhow, chasing the Wilson cycle, we're going to ask what the heck is a Wilson cycle. We're going to look at the different tectonic components of the Wilson cycle, and we're going to chase those components all over the eastern United States, both in space and in time, and see how they relate to other parts of the Wilson cycle. So hopefully this video will be useful to you. If so, please subscribe and give me a thumbs up if you like. And I appreciate very much all my wonderful subscribers. So here we go. Chasing the Wilson Cycle, video number 1. So what is the Wilson Cycle? Well, simply put, the Wilson Cycle means a supercontinent exists, for example, Rodinia. The supercontinent rifts apart into various smaller continents with oceans in between. Then convergence begins again. All those different continent pieces come back together to create a new supercontinent, and that is one Wilson cycle. And there's a guy after whom the Wilson cycle was named. I cannot remember his name right now. Mr. Dr. Oh well. Just kidding. The Wilson cycle was imagined and proposed by a Canadian geologist by the name of Tuzo Wilson. And I think his idea was very advanced for the time, so we're beneficiaries of this really smart guy. Today we're going to be looking at a part of the Wilson cycle called basement rocks. What are basement rocks? Every supercontinent has a central core, and that central core is made up of highly metamorphosed rocks, mostly granite gneiss, but there are other rocks too. When the supercontinent rifts apart, that core usually stays intact. And later, when convergence begins and continental pieces begin to come together toward that core to create a new supercontinent, the eroded and highly metamorphosed core provides the base upon which new additions to the continent are added. And that's why they call it basement rock. It's the ancient core rock that's left over from a former supercontinent. The basement rock usually gets covered up by new tectonic additions, but in many places the basement rock has become exposed by erosion and uplift and that sort of thing. And that's what we're going to look at today, hunks of the basement rock that are exposed all along the eastern United States. Most of our basement rock in the eastern United States is about 1 billion years old, plus or minus. And therefore it represents the leftover eroded and metamorphosed base rocks from Rodinia's supercontinent after it rifted apart. I look at the basement rocks as the very beginning of a Wilson cycle, because everything else that comes after and on top of these basement rocks represents subsequent components of the Wilson cycle. So let's take a look and see if we can find some exposures of basement rock in the eastern United States, how big they are and what they're made of. Let's head up to the beautiful Adirondack Mountains in New York State. Lovely Lake Placid. The area circled on this rock D geologic map represents and is the Adirondack Mountains in New York. And you can see that the basement rock here spreads all up into Canada. And those sections in Canada have different ages. The Adirondack Mountains themselves are about 1 billion years old. They represent 1 billion-year-old basement rock. But if you go to the center of the, as you approach the center of the North American continent up there where Canada is, the rocks get older and older and older, representing different phases of the Wilson cycle. We're going to see that on the Rock D geologic map, basement rock, old rock, Precambrian rocks, all the same thing, is usually represented as red or pink color. And when I tap on the pink color, Rock D says we have meta-anorthosite and anorthositic gneiss. Anorthosite is a super cool rock. It represents magma formed deep in the earth and now exposed by erosion, and it's made almost entirely of calcium-rich feldspar. And that gives it some little blue spots in there that look so pretty. There's a bunch of anorthosite around the Lake Placid area of the Adirondacks and in other places too. It is 1 billion year old plus or minus basement rock. And by the by, there's a lot of anorthosite on the moon. Now let's head down to Pennsylvania, near Reading, Pennsylvania, and check out some of the basement rocks associated with the Reading Prong. So why do they call this the Reading Prong? Because it's near Reading, Pennsylvania, and it's a prong of a mountain or a finger-shaped mountain that geologists decided to call a prong. Makes sense, eh? I don't know. And this geologic prong is made of Precambrian basement rock, about 1 billion years in age. The Rock D geologic map shows the Reading Prong area labeled in a reddish color. And this rock is made of felsic to mafic gneiss, predominantly quartz and feldspar. And this would not be the calcium-rich feldspar of the anorthosite. It would probably be sodium-rich or maybe even potassium-rich feldspar. Precambrian basement granite gneiss is usually light in color, and it's felsic. That means it has lots of quartz and potassium feldspar. And notice the stripes, the banding in all of these specimens. That metamorphic banding is what distinguishes granite from granite gneiss. Granite does not have metamorphic banding, even though both rocks have the same general mineral makeup. From Pennsylvania, we're heading south to Shenandoah National Park, and we're on Skyline Drive. And we're going to find a couple of really cool basement hunks here in the park. In Shenandoah National Park, we have Stony Man Mountain and Old Rag Mountain, both of which have ancient 1 billion year old basement rock. Here's the Stony Man Mountain profile. Can you tell why they call this Stony Man Mountain? The legends say that once upon a time there was a mean old codger that went around doing evil deeds, so the Great Spirit threw him on the mountain and turned him to stone. Here's the Rock D geology for Stony Man Mountain, and you can see that the top of Stony Man Mountain is not red or pink. That's because the top of Stony Man Mountain is made of Catoctin greenstone, which is a basalt lava flow that's younger than 1 billion years old, and we'll talk about that in another video. But underneath the Catoctin is basement rock. Alkali feldspar leucogranite. Well, alkali means it's got a lot of potassium in it, and they call it leucogranite. It's granite gneiss, not granite. Leuco just means very light colored. This is from the top of Stony Man Mountain. Grammy and I have hiked there. The official name for the Stony Man Mountain leucogranite gneiss is the Peddler Formation. We're talking basement rock. A few miles southeast of Stony Man, we find Old Rag Mountain. And it is made of Precambrian basement rock called the Old Rag Granite, which once again is really granite gneiss. Unlike Stony Man Mountain, Rag Mountain does not have a topping layer of Catoctin greenstone. It's pure basement rock. Rag Granite gneiss is cool because it has little hunks of blue quartz in it and large hunks of potassium feldspar. If I'm right, the blue quartz tells you that this rock has undergone a lot of metamorphism, and all that heavy-duty metamorphism results in an accumulation of rutile, which is titanium oxide, in the quartz. And the rutile needles refract light just like the particles in the sky, and that results in a blue color. If you go south on Skyline Drive in Shenandoah National Park, it turns into the Blue Ridge Parkway. So let's go south on the Blue Ridge Parkway to Grandfather Mountain in beautiful North Carolina. And why do they call it Grandfather Mountain? You guessed it, because in profile, it looks like an old grandfather laying on his back. Grandfather Mountain is basement rock exposed in a geologic window. That's when you have a relatively small area of land where the overlying rocks have been eroded away for one reason or another, exposing the rocks below, which in this case are basement rocks. One of the main types of Precambrian basement rocks associated with the Grandfather Mountain window is the blowing rock gneiss. And here is the blowing rock, called blowing rock because if you throw something off of it that's fairly light in weight, the object will go up instead of down because of the way the winds blow across the rock. Here is some blowing rock gneiss, and notice the large hunks of feldspar in it. Let's go on down to Georgia for our last hunk of Precambrian basement rock called the Corbin gneiss, or Corbin granite gneiss. The Corbin granite gneiss basement rock also has big hunks of feldspar in it. So what can we generally say about the Precambrian basement rock? Well, often it has metamorphic banding, sometimes it has blue quartz, and often it has large feldspar crystals. One interesting thing to me about all these basement rocks that we've talked about is that almost all of them are located in the western Blue Ridge geologic province. And this makes sense to me because the western Blue Ridge province represents the old eroded edge of ancient North America after Rodinia rifted into its several continents. Everything that's to the south and east of the western Blue Ridge, geologists call exotic terrains. These are geologic hunks of real estate that were added after Rodinia rifted as part of the assembly of our last major supercontinent, Pangaea. Okay, guys, that's it for Precambrian basement rock. Thank you so much for watching. If this was useful to you, please subscribe and give me a thumbs up. And this is your Rock Papa saying happy holidays and happy rock hunting to all my wonderful rock buds. Papa out.